Hello. Thank you very much for coming tonight to our first talk for the new science seminar series that we're putting on here at Berkeley City College. There will be one of these every 2 weeks. So be sure to check up wherever you found out about this talk. Hopefully you'll find out about more of them. We are putting this on the Department of Sciences. That's what I'm a part of. I'm an adjunct faculty member. My name is Sarah Cruz. I teach biology. And so we'll be putting on these talks from various sciences every 2 weeks. And there's a new science club here at Berkeley City College. And if you're interested in that, we have talked to this lady here, Jasmine Hayes, and she has all the information outside at the table. And tonight we're very honored to have Dr. Richard Muller here from UC Berkeley and the Lawrence Berkeley Labs. He's part of the Berkeley Earth Surface Temperature Project, and he's going to be talking to us about energy and climate, surprising things you need to know.
Thank you. Yeah, turn down. Well, thank you very much. I'm delighted to be here. My talk will be a little bit unusual, and that's because I'm going to emphasize the things that most people think they know but ain't so. Most of you probably know a lot about energy and about climate. And I'm going to talk about what is happening. About 2.5 years ago, my daughter and I created a new project we call Berkeley Earth. Sometimes it's referred to as the BEST project because Berkeley Earth Surface Temperature Project, but I prefer just calling it Berkeley Earth. And we began this project because of difficulties I had in coming to a good scientific conclusion about what is really true on issues of global warming and climate change. Part of the issue here is that many people who look into this subject become convinced that global warming is a serious problem, maybe the most serious problem that we're facing today. And once they look at that problem, then they get so concerned because the data are scientific data, you know, graphs and plots. And they say the public will never believe this, or they won't get excited, or they won't get interested. And at that point, they put political spin on it. They exaggerate it so that the public will understand. They perhaps say some things that aren't quite true or that are misleading, but which will bring the public to the correct conclusion, namely their conclusion. That's the way politics works. It's the way we do it. Everything outside of science, that's the way I do it. You know, who do I trust? Oh, do I trust so-and-so on the economy, or do I trust so-and-so? Which political person is most simpatico with my point of view? But when it gets to science, I can't do it that way. At science, I have to evaluate the data, and I found it very hard in this field. I have worked in cosmology, I have worked in particle physics, I have worked on elementary, you know, what makes up the nucleus. I've done all sorts of things, but of all the fields I've ever worked in, this has been the most difficult. And the reason is because people are so concerned about it, because they get so worried about it, that they start presenting to you not the evidence, but their version of the evidence. They pick and choose. I call it cherry picking. Pick and choose data that supports their point of view and hide the other side, like a lawyer, not like a scientist. So as a result, I started this project because the project was so important, and mostly because I wanted to satisfy my own curiosity, my own concern about what is going on. So I'm going to start by showing you really our conclusions. It's not just climate change. The issues I'm going to talk about: climate change, how much is there, what is it affecting, what aspects of climate change are going on, how much is human, and if it is bad, what can we do about it? By the way, my assumption is it's bad. Any change, any dramatic change to the whole world, I take as bad. Now, some of my friends, like Will Happer, think, oh, global warming is going to be good. But I believe it's bad for reasons I can talk about. It's not my area of expertise. My area of expertise is the science. But we'll talk about what is happening, what we know about happening, and we have some dramatic new results that I hope you will not only find fascinating, but you'll actually enjoy watching. I'm going to show a little movie. Secondly, there's the issue of energy security. And this is closely linked to issues of climate change. I frequently find, for example, when I talk to a Republican and I talk about climate change, that he starts talking about it, or she, they start talking about it. Before you know it, they're talking about energy security, not about climate change. On the other hand, when I talk to a Democrat about energy security, I find very quickly we're talking about climate change. They like to change the subject. So there does seem to be an issue here and a conflict. Some things are not in conflict at all. So for example, the primary solution to anything in today's talk, the most important thing you can do is called energy efficiency, energy productivity, energy conservation. That's something that, in principle, nobody should object to. And it's a win-win. You make money and you do good on all of these fields. I'm not going to go into that in very much detail because I think to most of us it's pretty obvious. Why doesn't the public buy it? I think it's sold the wrong way. And I have a new book coming out this summer called Energy for Future Presidents. I'm, by the way, the guy who created the course Physics for Future Presidents on campus. Taught it for 10 years. But the new book, Energy for Future Presidents, will go into that in great detail. So if I don't say anything more about energy conservation, the reason is simply I believe most people here know that it's good. You don't need convincing. The question is, how do you get the rest of the general public to recognize that it's win-win? Not only is it good for the environment, but it's also good for their lives, and it's also good for their pocketbooks. And I'll talk a little bit about the economics of it. And this is also extremely important. The economics are important because we've found, for example, that concern about global warming in the United States has plummeted as soon as the economy went bad. Is that related? I certainly think it is. People have something else to worry about. So the impact on economics is very important. And you can ignore that. You can be righteous and say, oh, forget the economics. We've got to do what's right. But you're not going to sell people in Washington who have to get reelected. So if you're looking for a practical solution, and I am looking for a practical solution, in the end, I'll present what I consider the only practical solution. Energy conservation is great, but it can only go so far. I believe there's a problem. I'll show you what I think that problem is. And then I'll talk about the solution to that problem, which is one that I believe you have not heard. This is a brand new idea that I've only had for 2 months now. It's in my new book that's coming out this summer. But you'll be a little bit surprised. You may not like it. It has an aspect to it that most people, I've told some of my friends here in Berkeley about this, and they, oh, no, 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 no. You have to get into the details to realize there is not much in the way of a solution that will actually work. There are feel-good solutions. I worry a lot about Berkeley. I imagine the following future as being the most likely scenario. That 50 years from now, we will have terrible global warming. And it will cause difficulties around the world, in agriculture, in lives, everything. I consider this likely. And Berkeley, what will we be saying in Berkeley? We'll be saying, well, at least it wasn't our fault. We did our part, and the rest of the world ignored us. Well, I don't consider that something to be proud of. If you do something that the rest of the world will ignore, you should have known that all along. And being self-righteous and saying, it's not my fault, no, it is your fault. We have got to do something that will really work. Now, is global warming really going to be a problem? I'm not sure. I don't know. You'll see that in my talk. There's too much uncertainty. How bad a problem will it be? I don't really know. But what is clear is we are playing in the ballpark in which big things can change. When I was a kid, I grew up in New York City. I'm sorry. When I was a kid, I grew up in New York City. And in New York, we used to dump all the garbage in the oceans. And everybody said, the oceans are so big, you can just dump the garbage in, and it goes away. Okay? We know that's not true. Well, we are now doing this with the atmosphere. Maybe it's okay. Maybe the carbon dioxide will be good. But we've got to recognize that we are playing a game in which we are in the realm where for the first time, maybe not the first time, but certainly a realm in which humans can really affect the climate. Maybe they won't. Maybe things will cancel out. But we're playing in that game. And just for that reason alone, I think it's wise to be cautious. So with that introduction, Let me first show you something that has not been shown publicly before, which is the results from this temperature study that my daughter and I created. I've got to mention the name of Robert Rohde, R-O-H-D-E. I had one act of genius in this temperature study. It was to hire Rohde. He was the right person. And just remember his name. You'll be hearing a lot about him in the future. Not in the future of this talk, because I'm not going to dwell on names, but I want to give him enormous credit for the role that he played as our chief scientist. And let's begin with these new results, which have not been shown publicly before. We have reanalyzed the temperature, all the data from the thermometers until really going back until Fahrenheit in the early 1700s invented the first reliable thermometer. And we have gathered together most of the world's data on this. Some of it hasn't yet been transcribed from pieces of paper, but the data that's been digitized, we have gathered it together. We have put it into a unified database. And we're already getting enormous thanks for having done this. We've put it in a database, and we've put it online. We've put it online. You could download it tonight if you want. 1.6 billion points. It'll take a while to download. But it's there in a format that's easy to use, and it's on the website berkeleyearth.org. Berkeleyearth, one word, .org. All the data is there, and already we're getting international acclaim for having done this. You see, it used to be in 14 different files in 14 different formats, and you had to analyze that was really tough. But Rohde has taken all that and put it into a unified format. So now it's available for everybody. We're hoping that this will bring a lot of people into analyzing these data. Okay, let me show you the results of this analysis, which quite frankly surprised me. But they would have surprised me no matter what, because when I started this work, I wasn't sure what the answer would be. Previous groups, including the IPCC, had published data, but there were so many questions raised about the data that I felt there were legitimate concerns, and it might turn out, for example, that there was global cooling. So here is our result. This is the temperature history. Now I have just multiplied by 10 the number of people who've seen this, because these data from 1750 have not been made public yet. This rise here is what people refer to as global warming. According to the IPCC, this is the by the way, you should know the letters IPCC. If there are any students here who don't know it, learn it now. Memorize it, write it down, write it on your wrist. Go home saying IPCC. IPCC is basically the UN of the climate phenomenon. They're the group organized by the UN and the World Meteorological Organization that puts together every 4 years or so, 4 or 5 years, they put together a big report. When people say there's a consensus, that's what they're referring to. Doesn't mean the consensus is right, but you've got to know who the consensus is. And it's the IPCC. You don't have to know that that stands for the Intergovernmental Panel on Climate Change, any more than you really have to know that UN stands for United Nations. I mean, they're not united. What's going on? But IPCC, that's the consensus. And they're now writing their next version of the report. And they have data going back till around 1880, somewhere around here. And they say that this recent rise is a departure from natural phenomena. What are natural phenomena? Well, the sun is changing, and they conclude that the gradual warming from here until 1957 could be due to natural causes. It could simply be an effect of the changes in the sun. A lot of people don't know they say that. People complain, oh, they ignore natural phenomena, they ignore the sun. It's not true. People who say that haven't read the report. They conclude that this warming may have been coming out of the Little Ice Age, and right up until around 1957, that's right about here, that could be completely natural. By the way, what are these huge swings? Well, let me first tell you, they have never been seen before in such complete data. And we know what causes them. There was a huge volcanic eruption right here just before this started to drop, a huge volcanic eruption there. There were 2 big volcanic eruptions there. There was another one right there. These are volcanic eruptions having a big effect. These swings are huge. I mean, a lot of the people who want to scare you about climate change say that this rise in temperature is unprecedented. It never happened before in the history of the world. Well, that turns out not to be true. And I wish people didn't make up statistics like that simply to make their case. Because then when more data come in, you find there are rises here that are much steeper than anything we're experiencing now. And so what they said turns out technically not to be true. I don't like listening to the exaggerators. Let's just listen to the scientists and see what they say. Now, it was the steepest, since 1870, but now we see these big changes. We know what causes those. Those are volcanoes. Fascinating to see what a huge effect volcanoes have. Some people think this is periodic, has about a 20-year cycle. Hey, maybe that's sunspots. No, it doesn't match the sunspots. We're writing a paper on this now that we'll submit, I hope, within a week or two. And it doesn't match the sunspots. So there it is, and there's global warming. The IPCC, in their models, they account for this rise due to sunspots, but then the sunspots didn't keep going up. And there are no volcanic eruptions of real high magnitude. There's Pinatubo and El Chichon, but those really didn't affect these data very much. And so they attribute, what they say is most of this warming is due to humans, most. They don't define most. I take most to be more than half. We've got to recognize that that means there's a factor of 2 uncertainty in how much is caused by humans. And that makes a big difference. Because if you have double the rate, you have much less time to do anything about it, presuming you do want to do something. And if it's only half the rate, you have a lot more time. So it makes a big difference. And we're trying to address this now in our study, how much is due to humans. My inclination right now, based on our preliminary work, is that it's closer to half than 100%. But next week, I may feel differently on that. But we are analyzing that, and we're trying to get an answer. So there you have global warming. Is this close to what people had said previously? The answer is yes. It turns out over in this region, we agree very closely with what previous groups had gotten. So I have what I call valid scientific skepticism. That means every scientist should be skeptical, should open it with a fresh mind. If we had gotten the fact that this was just going flat across, I would have accepted that, and that's what I'd be talking about tonight. But it didn't. It turns out what we found is that the rise is close to what the other groups had found. That doesn't mean that we know how much of it is due to humans. And you'll find a lot of people who use a rhetorical trick of saying, well, this global warming has been shown to be right by Muller and Berkeley Earth. Now, then they will go on and simply assume it's all due to humans. And they conflate global warming with human-caused global warming. And they'll say, what can we do about this? We caused it. What can we do about it? Well, not according to the IPCC. According to the IPCC, we caused half of it. And I'm not even sure of that, because I'm still open-minded on that issue of how much is caused by humans. And the main problem with the IPCC conclusion is they say, well, we understand volcanoes. We understand sunspots. This departs from the volcanoes and the sunspots. And they throw in aerosols due to humans. Because it departs from them, they say it must be caused by humans. That is actually their logic. They say there's nothing else natural. Well, I think there may be other things natural that have to be looked at. And so we're looking at them. We think there may be, like El Nino. That's a natural thing that changes every few years. We think there may be other things, too, that have to be looked at. And so for that reason, we can't be sure how much of this is caused by humans, but let's assume that at least half, maybe all of it is, for the rest of this talk. Now I'm going to show you something that is actually on our website. And what we've done here, this is a map of the globe. This is 1850. I don't go all the way back on the map, 1850, and then up to the present. And this shows the area of the world that we knew something about based on thermometers in 1850. You see it's mostly the northern hemisphere. But I showed you a moment ago the plot of the temperature. This is a map of the temperature. It shows what parts are hot and what parts are cool back in 1850. And down here is the curve. And we'll have a little, as I'm going to show this, it's a movie. You're going to see a little red dot moving on this. And here's the global warming. It's stretched out, so it doesn't look so dramatic, but that's the global warming. And now let's watch it on the map, on the movie of the map. So let me see if I can get that going. Okay, here we are. You see the temperature is bouncing around. And we only have partial coverage of the Earth, but you see hot spots and cold spots and hot spots and cold spots. They're jumping all over the place. There are clues in that about what's going on. Much of this is El Nino, and a lot of it is the North Atlantic temperature. We know those things change. Are they changing? The El Nino is a natural cause, and they cause a lot of these things. In fact, if you want to know whether it's going to be rainy or dry in California, the best thing you need to know is what is happening in the equatorial Pacific. That's where El Nino is. Now we're getting up 1875, and we're getting much better coverage. We're picking up some South America, we're picking up Australia. Not much in Africa yet. There's a little bit of Africa. These temperature stations come and go. I'll tell you, collecting 1.6 billion points is a lot of work. But look at the changes here. It's cooling in some places, warming in others. There's a heat spell right up there in the Caucasus. Watch it. We're getting to 1900 now. We're getting pretty good Earth coverage. Still no Antarctica. This kicks in around 1955. But it turns out not to be much area, just a few % of the world's area, so it's not that important. We only, okay, so there it is jumping around. And you see how variable it is. If you are trying to detect global warming, you have to detect it on top of these natural oscillations, variations, and pulses. The total temperature is shown over here with the bar. The average here is 0. We simply define that as the mean from 1950 to 1980 so that we have a nice plot. So again, you see these hot spells. Where are we getting them? 1924. Watch for 1933 or so, because we had the Dust Bowl. And I found this fascinating when we finally got this result. Look at that, Canada, East Coast. There's the Dust Bowl. But it was local. It wasn't worldwide. I'd always assumed it was worldwide. I assumed the Great Depression of that time, which was worldwide, was associated with a worldwide climate event. But it was local. That came as a surprise to me when I saw this. Now we're getting up closer to the modern era. We're about to pick up a little bit of Antarctica right now. We're about to pick up most of it. And then we have good land coverage. We haven't done the oceans yet. And we're going to be doing that in this coming year. If anybody knows any good foundations who want to help us do the oceans, please let me know. OK, now we have very good coverage. We've gotten Antarctica. Things are pulsing. This one doesn't quite get up to 2010. But look at those pulses. Remember this movie. It's online. You can download it. It's on YouTube. And actually, one museum is mapping it onto a round globe. I'm going to show that. And you can see these hot flashes. What's that? Well, of course, everything is getting warmer. So when everything is warmer, you're more likely to have a hot flash. But nonetheless, now it's getting pretty red. That's because of where we set the scale. At about 1 degree of global warming, it's getting pretty red. 1998, 1999. As I said, this doesn't go all the way up to 2010. I think online we have a more recent one. I hadn't realized I brought the shorter one. So there we are. There's the global warming. Now somehow this is a little bit more dramatic than seeing the little red dot bounce up here. And of course, we did that on purpose. We made it red when it gets up 1 degree. 1 degree, that's not much. And this is the land. If you average in the oceans, you know how much the IPCC says warming has been on the globe in the last ever due to humans? No, part of it. How much the rise of the last 50 years is the only part that they attribute to humans. And that's been 0.64 degrees Celsius. 2/3 of a degree Celsius. That's the global warming. That's pretty small. Prior to that, everything is natural, or could be. 0.64. How do you notice 0.64? Well, the answer is it's really very hard. Let me show you all of the temperature stations in the United States that have been recording information for the last 100 years. So I'm going to show that. Here's a map of all the stations, and it's amazing how many there are. The US has been very scientific and very good about this. So there's the US with all the stations that have recorded temperature. They're either X's or O's. The X's are areas that show net warming over 100 years. The O's are stations that show net cooling over 100 years. Well, it looks to me like there are more O's than X's. Turns out not to be true. That's an illusion because the O's have a little, they were printed second and they sit on top of the X's. So you can't just measure from the color. It turns out there are twice as many X's as O's. So what that means is it's actually very closely related to the global warming. Twice as many X's as O's. So on average, we have warmed on the land by about 0.9 degrees Celsius, more than on the oceans. 0.9 degrees Celsius. We have warmed in 100 years. Have you noticed this? No, you have not noticed this. You may go outside and say, oh, it seems warm today. But no, you can't notice 1 degree Celsius over 100 years. It's an illusion. It's an illusion driven by people who are deeply concerned over these kind of effects. Twice as many warm as cold. That's bad. It fits in with the model and the understanding of the greenhouse effect. And therefore, we're really concerned about it. But the public isn't concerned from plots like this. I mean, it's so small. How can you get anybody concerned about 0.64 degrees? It's very hard. So what do? You say, oh, the polar bears are dying because of this. By the way, that has been contested legally in the courts. And the court found that there is no evidence that any polar bear has ever died due to receding ice. And they forced the people who wanted to spread the Al Gore movie into every classroom of the UK. The judge decreed, after having listened to evidence on both sides, that they can distribute the movie to every school in the UK, provided that they also distribute a list of 10 major errors in the movie. One of them being the polar bear thing, which is just not true. Zero evidence for that. But a famous global warming proponent was once asked, why do you talk about the polar bears? And he says, because I believe it's true, even if the evidence doesn't show it, and people can visualize it then. But they think it's based on science. And part of the problem in the United States is when people learn that they have been lied to or exaggerated to, they tend to flip and go the opposite way. And this is a real danger in exaggeration. You may win people over, but as time goes on, they learn that what you've been saying is wrong or exaggerated, and then they lose interest. And I fear that we're partly in that now, in large part because people have systematically gone through an inconvenient truth. And 80 to 85%, I've done this myself, is either wrong or exaggerated or misleading. And I'm not a fan of that movie. I am concerned about global warming. But I fear that when Al Gore made that movie, he didn't respect the public enough. He wanted to galvanize people into action. And it did. It worked. It woke up the United States. And now we're losing the United States for the same reason because of that movie. Anyway, remember that plot. That's an interesting plot. Tornadoes. What about all these other things? Tornadoes are increasing, right? You can see that in An Inconvenient Truth. Tornadoes are increasing. Well, this is the official US government report, 1950 to 2011. What about these terrible tornadoes that we had just in this last year, in 2011? Well, they hit some cities, so there are a large number of casualties. But the violent tornadoes have been gradually going down. Now, why do I include only the violent tornadoes? The reason is, if you include the little tornadoes that never touch down, our detection methods have improved enormously over the past 30 years. We now detect them with radar. And so we report a lot more tornadoes, and this is what Al Gore does. He reports a lot more tornadoes, says the number of tornadoes are going up. If you take only the ones that we would have detected back in 1950, you can see the trend is gradually down. Does this contradict global warming? No. Global warming does not predict that the number of tornadoes will go up. If you look carefully, next time you see this, you'll see what the scientists say is that some global warming models predict an increase in the number of storms. Do they all predict that? No. Some global warming models predict fewer storms. This is not a test of global warming. When people talk about climate change, they say, oh, well, what about tornadoes? What about Katrina? What about the terrible damage done by Hurricane Katrina? Well, let's look at number of hurricanes hitting the United States. Anytime a hurricane has hit the United States since 1850, it was well recorded in the newspapers by scientific measurements, wind measurements. The US East Coast has been extremely well instrumented. And so we know the number of tornadoes at the coast. The black ones are all the hurricanes, including categories 1, 2, 3, 4, and 5. And you can see that they're level. Maybe they're going down a little bit. If they're going down, does that contradict global warming? No, global warming doesn't predict more hurricanes. When you see people saying there are more hurricanes, and they say, and that's consistent with the predictions of global warming, which is sort of technically true but misleading. What about the violent ones? Here's the category that Katrina was in. Katrina was a category 3 when it hit New Orleans. It wasn't a category 5. It was a category 3 when it hit. And you can see those are pretty level too. Maybe going down a little bit. What about the most violent, the 4 and 5s? Well, here they are in red. And you can see they're pretty constant too. Maybe going down a little bit. Are there more hurricanes? Oh yeah, there are a lot more hurricanes now than there used to be. Named hurricanes. In 2006, we ran out of names. Oh, let me show this one here. Here's why. This is the 2005. Oh, that's when we ran out of names, 2005. That was the Katrina season. You see all these hurricanes out at sea. If you go back to the early years of the century, there were no hurricanes out. Lots in here, but there were none out here. That's because we didn't have satellites, and we didn't have remote buoys that would report on hurricanes and winds, and because ships avoided that area because it's a dangerous place to be if you run into a hurricane. So we didn't have many hurricanes there. This is an observational bias. Now, Al Gore doesn't lie. In Inconvenient Truth, he says, and the number of named hurricanes has increased enormously over the past 30 years. And that's a true statement. What he doesn't tell you is that the number has increased because we now detect many more in regions that we used to miss. And when you look at an unbiased subsample, something that we wouldn't miss them one way or the other, you find there's no evidence for an increase. In fact, there's a slight statistically significant decrease. I don't call it significant because it's not much of a decrease, but certainly it is a statistically significant decrease. So no, the hurricanes aren't going up. And Katrina was only a category 3. And look at all these category 3 storms, and there are a little bit fewer of them now, but one of them happened to hit New Orleans, just like a couple tornadoes happened to hit big cities instead of trailer parks. And so the casualties went way up last year. But it doesn't mean that they're getting worse. It just means we have more of a population. And we were unlucky that year. Some people say the temperature from the last 15 years has not been increasing anymore. Is that true? Here's the temperature from the last 15 years. I don't include our data here because we don't include the oceans. But there's the temperature for the last 15 years. That's 0.5 degrees Celsius. Has it been going up or not? Many people are looking at this, and I think a lot of opponents of taking action look at this and say global warming has stopped. And I don't think that's a proper conclusion. If you look at the true global warming curve, you find it stops lots of times. It's sort of like a stair step going up. And what we say in our most recent paper, about to be submitted, is that based on our data, we cannot draw any conclusion about whether the warming has gone up at the constant rate or whether it has stalled. But you'll come across this. And I think a lot of people look at this and they say they're hoping it has stopped. And part of the reason to hope it has stopped is if you look at the whole issue in an objective way, you will conclude that nobody, not Tom Friedman, not Al Gore, not President Obama, nobody has publicly suggested any approach of anything the US could do that has any chance of stopping global warming, presuming it is due to the greenhouse gases. That's a very strong statement for me to make. None of the 360, the 350 organization, what they're suggesting will demonstrably not work. I'll show you why in a moment. Let me finally mention Climategate. Okay, this is the famous hockey stick plot. That's my famous unstable computer, which, go back there. Stop that. Okay. I'd like to do it on this plot for some reason. So here is what's called Little Ice Age, and then you see the temperature shoots up. And I have many colleagues at Berkeley who saw this plot and say, well, the public may not like graphs, but I understand them, and this is clear and incontrovertible. Climategate happened when a bunch of emails and the raw data were made available to the public. Most people say they were hacked. But quite frankly, I think the evidence is much stronger that a member of the team leaked them. a member of the team who didn't like the suppression of data. When the data were released, let me show you what the raw data looked like. This is important. Here is the Climategate raw data, the way it really was. Let me flip back and forth. Whoops. How do you get from raw data like this to this? Let me show you the logic. Wow. I don't know why this slide always does this. Maybe it has a timer on it I have to take off. Anyway, I'll try to bring it back when it does happen. The logic was this. We know that it has warmed. This is indirect data of temperature. It's all tree rings and cores from corals and things like that. So it's called a proxy. It's indirect. And there are big swings. Look at those disagreements. Huge disagreements. And here there's a huge disagreement. But we know the thermometer data showed an increase in this period. So therefore, and they didn't really fully explain this in their paper, what they said was the data from here on are unreliable. And this was based on looking at the data. Now, that's not something you should do if you're a scientist. And therefore, what I would have done if I had reached this conclusion is I'd show this plot. I would argue that the data are unreliable, and we could replace them with the temperature data. And what they did is they decided to stick the temperature data on here on the peak, and from here on, go up in the temperature. So they erased the bad data, what they called bad data, put on the temperature data, and they came up with a clear and incontrovertible plot. Is that science? No, that's politics. Do I approve? Absolutely not. Did they break any law? No. Will I ever read their papers again? No. I have learned I cannot trust these so-called scientists. Did they do anything illegal? They did not. What I call this is scientific malpractice. The sort of thing which, if my graduate student had done it, I would have said, I'm sorry, you're no longer going to do research in my group. If a colleague had done it, I will no longer collaborate with you. And for the people who did it, I really don't want to read their papers because I can't trust them anymore. If they had done it the way I suggested, that is, show the data and then give their change and explain that would be fine. But when they were asked under the Freedom of Information Act to release the original data, they refused to do it. They felt it would be misleading to release the original data. So they refused to do it. This is, in my mind, a scientific scandal of the first. They were exonerated by their local people who went and never even looked at this plot, by the way. They just asked them to review what this group had done. But this, to me, is absolutely shocking. And it's another reason why I believe there's been so much skepticism. Because you look at this and you say, who can you trust? And I believe there are people you still can trust. But this group I'll never trust. You saw my results. There really is significant global warming. Just ignore this. Forget this. Don't use this to reach one conclusion or another. You can't trust these people. But there is real global warming. I showed that in my plot, the very first plot I showed you. Okay. What did President Obama say on the State of the Union message? You recall what he said in the last two States of the Union message? In 2011, in the State of the Union message, I listened eagerly to see what he was going to say about climate change and global warming. You could look back on it, it's online, and you will see this issue, which was so important in his campaign, he neglected to even mention it. Why? I think I know why, and I'll show you in a moment. What about this year? He did mention global warming. One sentence on climate change. This is that one sentence. Okay, so there's nothing there. This is it. The differences in this chamber, he was in the chamber of the House and Senate, the joint chamber, may be too deep right now to pass a comprehensive plan to fight climate change. That was it. Why has he given up? I believe there's a real reason. Part of course, is the recession, when people have lost interest. Part of it is the disillusionment of people who were brought on board by stories of polar bears and now know that's not true. I think a lot of harm was done not only to global warming, addressing global warming, but also to the credibility of science by the way scientists have behaved in this thing. But let me show you why I think the real reason is. Let's talk about greenhouse gases. Carbon dioxide emitted into the atmosphere tends to absorb the heat radiation. And therefore, it bounces it back, and that's like putting a blanket on. And that's a real effect. We know that's a real effect. Without the atmosphere, we would all be below the freezing point of water. We know that, just from the radiation balance. But the fact that it absorbs the heat radiation, infrared radiation, and sends it back, acts like a blanket, and we get warmer as a result. Now, the blanket is a little bit leaky. Some of that radiation gets through. You add carbon dioxide, and it tends to bounce back more. So the carbon dioxide has that effect. I believe that 100%. There may be other effects, such as cloud cover, that changes when you add carbon dioxide. And let me ignore that for now. I know a lot about that subject too. But let's just assume the ordinary greenhouse gas is working. Let's look at the key greenhouse gas. Methane is important too, but the key greenhouse gas is carbon dioxide. Let's look at the United States increase in carbon dioxide over the past recent years. And let's compare that to the increase of emissions from China. And this is a plot that you haven't seen. The data are available. They're published by the US government. No, actually, they're published by the Netherlands Environmental Protection Agency. They'll be in my new book. Ready? US yearly emissions of carbon dioxide. The units are billions of tons per year. Okay, 5 billion, 6 billion. Here's the US. We started going down. Is that because we signed a treaty? No, it's just the recession. Part of it is replacing our coal plants with natural gas. That's actually a significant part of it. Coal is so dirty. Natural gas emits only half the carbon dioxide of coal. It still emits it. It's a greenhouse gas. But for the same energy, it's half. Why is that? Because coal is C. It's carbon. You burn that, you get carbon dioxide. Natural gas is CH4. You burn that, you get carbon, but you also get water, H2O. And that's fine. It doesn't affect anything. The amount of water in the atmosphere is not affected by burning coal because it's affected by the fact that there's so many oceans. But look what happened here. In 2006, China has been soaring. Their economy has been growing at 10% per year. During the recession, I think it was 9.8% or something like that. And they've been building a new gigawatt. You know what a gigawatt is? It's the biggest power plant we have is a gigawatt. They've been building 50 new coal-burning gigawatts per year. They've also been building about 1/6 of a gigawatt per year of solar. Now, you hear a lot about the great surge in Chinese solar power. 1/6 of a gigawatt per year compared to over 50 in coal. It makes them look good. They're doing solar. They have more solar than the US. It's minuscule. Unless they're going to switch over from 50 gigawatts a year to, I mean, we're talking here about 300 times more coal than solar. If they're going to grow solar by a factor of 300 in the next 5 years and replace that, then there's some chance that this will do some good. Now, here's the problem I believe that President Obama faces. He's saying, you want us to cut back even more? What good will it do? Let's assume China. China has offered to cut back to 6%. Problem is, they say they've already cut back to 6%, but the Dutch estimates say 10%. Let's say it's 6%. Let's assume they're going to cut back to 6%. By the way, when they offered this, it was put on the PBS NewsHour as the Chinese have offered to cut their emissions by 4% per year. The NewsHour missed the fact that what they were talking about was relative to the economic growth. So the Chinese never offered to cut back on emissions. They were going to slow the emissions compared to their economic growth. They were offering, basically, to grow at 6% instead of 10%. What would have happened if they did that? Well, here's my plot, just projecting 6% growth. And here's the US, assuming we signed the accords in Copenhagen, we would drop to 20% of what we were. Hardly matters if we drop to 20% or stay at 100%, or even double. You can see the emissions in the future are totally those of the developing world. How does President Obama address this issue when the Republicans are so prominent and they're going to raise it? They're saying, what are you doing that will bring the emissions down? What does the 350 movement, what does it say? It says, oh, we will cut back ourselves. They're a big Berkeley. They will cut back, and then they will not be responsible. And China will follow our lead because they'll follow our example. China's a poor country. They can't afford to follow our example unless it's really cheap. And the things being proposed, from electric automobiles to carbon sequestration, are not cheap. There is one thing that's cheap, and this is the thing that many of you will not like to hear. We could at least cut their emissions in two, from up there to down here, by having them stop building coal-powered plants and have them build natural gas-powered plants. What that means is an enormous fracking effort in China. A lot of you have heard of fracking. You probably think it's terrible, it's environmentally bad. Let me tell you, after looking at all the numbers, it's the only approach that has any chance of really doing something about future global warming. Other than luck. I mean, it's always possible the theory's all wrong. I don't believe that. And we can encourage fracking in the Soviet Union, in China. We can do that. Let's address energy security, because we're running a little bit short on time here. These are the oil reserves by country, and you see here's the US with very few oil reserves remaining, and here's Saudi Arabia, the king of oil, and this one doesn't show Venezuela, which is also large, and it shows this one here, which is Canada. A few years ago, when the price of oil dropped, Canada's reserves dropped because it's expensive for them to get oil out of their oil sands. And so how much they have depends a lot on the price. Anyway, reminding you about the global warming. That's our curve. It's real. I may come across as a skeptic. I think I'm only properly skeptical. I'm skeptical of all the things that are brought in to try to convince you to get up and do something. But when they're false, I don't believe you should be presented with things that are exaggerated, like Hurricane Katrina was due to global warming. Let me show this plot again. And now let's add in the natural gas reserves. And these are new. I'll show you that in a moment. These are remarkably new. Let's add in the natural gas reserves and look at that. Okay? These are in the same units, barrels of oil equivalent. But look at the United States. Look how much fossil fuel we have. A huge amount. Or in terms of energy security, we are not running out of fossil fuels. We are simply running out of liquid fuels, but that's the kind we use in our automobiles. And China, I think the Chinese number is much larger now. This is an old plot. It's somewhere up to here. So that offers a chance. Sorry that I got that old plot in here, but the new numbers keep on increasing. And we're not that far below Saudi Arabia anymore. Let's add in our coal, dirty coal. Shows you the problem. Oops. Oh, that's our shale gas. That's where it all came from. You'll hear of things like the Marcellus Shale, and you'll be seeing this in the news. This is the biggest energy issue in the United States right now, is how much fracking we're going to allow. And fracking people worry about it because the water, traditional fracking, you just pour the water into the countryside, it kills the fish, it kills the area, and that's bad, bad, bad. And therefore, hey, that's an unsolvable problem. No, it's not an unsolvable problem. It's an easily solvable problem. You just find them if they do that again. I think that's an economically very easy thing to do. So I believe fracking can be made clean, and I can tell you a lot more about that. But this is the natural gas in the US. And this is from the shale gas. And look, it started shooting up. When? 2007, 2006. Look at it going up. 30% of our natural gas is now coming from shale gas. And it's continuing to rise. We have these, the fracking technology is fascinating. And it means that this natural gas, which was in the rock, we can now extract so economically that the price of natural gas, which had been up to $14 per million cubic feet and had dropped down to $8 and was hanging there for a while, now down to $2.50. Now, this may not be reflected in the price you pay for natural gas at home, but it will be. And the people I know in the gas industry are despondent because these are old timers and they own the old wells, and now the price has gone down from $8 to $2.50 because these new fracking is so cheap and giving so much natural gas, and there's a huge amount in China. Okay, I call it the shale gas rush. It really is. And if you don't know about this, it's simply because many Berkeley papers are hoping it will go away. But in terms of energy security, it's enormous. And half the taxis in San Francisco are already converted to run on natural gas because it is it's 7 times cheaper than gasoline. If you really care about the cost of gasoline, you'll switch. I'm sorry, it's more than 7 because the price of gasoline has recently gone up, and I didn't include that in. I assumed that gasoline was $3 a gallon. So it's a bigger difference. It's really cheap. And you don't have the range. You can only go 100, 150 miles if you put in one of these tanks in your car. But we are in the beginning of a revolution. Now, this is still a fossil fuel. So it still emits carbon dioxide, half as much as coal, and less than gasoline, but still a lot. So this is the conflict. Okay, I said this about the natural gas. It's really cheap. This oil and gas. Now I'm going to add in something new. I added in, let's add in coal. So that's if we add in coal. And you see, we are the king of coal, king of fossil fuels. Look at that. It's huge. That's the danger, coal, because it has the most carbon dioxide per kilowatt hour of energy. And we have huge amounts, and Saudi Arabia is way down here. They have almost no coal whatsoever. So we are the king of fossil fuels, but it gets even more dramatic when I add in something that I bet you have not heard of. Maybe 1 or 2 of the professors here are familiar with this. Almost nobody else is. And just remember, you first heard it here, because this is going to be bigger than natural gas. And this is shale oil. Shale oil, these rocks contain oil in them. How can you get the oil out? It's been around for a long time. Estonia actually digs up the rocks and heats them up and extracts out the oil. Very expensive process. But now that the fracking has worked, the US oil companies have developed some new techniques. What they do is they go down there and they fracture the rock, and then they heat it up. They spend 3 years heating it up, and the oil gradually converts to what's called sweet oil, which flows very readily, and then they pump it out. And as a result of this method, and do some other enhanced oil recovery methods, 2011 was the first year in over a decade that the US actually produced more oil than it imported. Now, half of our trade deficit comes from importing oil. And this is a big deal, as you know, throughout the US, the trade deficit. If we could stop importing oil, and I think we're on the verge of doing that, this is growing faster than natural gas. It has more carbon dioxide than does natural gas. The main use in the United States, we don't burn oil for electricity anymore. It's almost all used for transportation. But we have these enormous reserves. And a lot of them are in Texas and Louisiana and places where the local government is happy to license them. This is going to happen. And if you oppose it, you need to know it's going to happen. But it really addresses the liquid energy security, the security for our automobiles. Okay, how much do we have? Enormous reserves. Remember, here's our oil in red. There's our natural gas, which brings us close to what China is. There's our coal, which nobody likes. And there is the shale oil. It's huge, huge. And this is coming. We're on the verge of an energy revolution, which may be very bad in terms of global warming. But remember, it's China that's the biggest issue. And I think this also is an old plot. The Chinese reserves, as they've explored more, have gone way up. Enough so that they could actually substitute this for coal. So I apologize for having the outdated plots. Okay, what else am I going to say? Oh, this is Shale Oil. This is their plant where they're heating the oil underground and extracting it. And they're getting it for about $30 a barrel. And that's cheap. The oil sands are about $60 a barrel. And as you know, oil is selling for over $100 a barrel now. So it's very attractive, and there are huge reserves. And here is the monthly production, and you see it turning up here. That's amazing. What about Hubbard's Peak? Well, expect that to keep on going up. Regardless of your politics, regardless of what you think about global warming, this is what is happening. Okay. Oh, I don't really have time to talk about Fukushima. Let me just say, I went through some careful calculations to calculate the expected number of cancer deaths from Fukushima, and the number turns out to be approximately 100. Why is the government making a big fuss about Fukushima? Well, because they can't do anything about the next tsunami. They're not doing anything to protect against the next tsunami. This was 15,000 people killed by the tsunami. So what do you do about it? Build a 50-foot wall around Japan? No, there's nothing you can do. You're sitting there exposed. Oh, what you could do is talk about a nuclear reactor. Hey, it killed, let's not say how many, because people really worry about it. And it distracts, I think, from the bigger issue. Anyway, the nuclear waste storage is something I've really worked through a lot of calculations on, and it's not a difficult problem. I'm running out of time. Let me just summarize. Here are the things from this talk that I want you to remember. China and the developing world are the main players in global warming, not the US. Anything that we do, if they don't or can't afford to follow our example, will do no good. We can help them develop shale gas. And I have specific proposals for a way of doing that I've discussed with some of the top energy people in the US. I believe we could really help them do that and encourage them to do that. If you oppose fracking, you might oppose that. I think that would be a mistake from an environmental point of view. Natural gas, if you really believe in solar, and I'm a fan of solar and wind, and the main danger, and also of nuclear, I'm a nuclear fan, but the main danger to them is that they will be more expensive than energy from natural gas. That's going to be their economic issue. That the energy crisis is for transportation fuel, and that's about to, I say whale oil, rock oil transformation. Oil in the US used to be whale oil, and it was used for lighting. And then they discovered this thing called rock oil that they could get out. We now just call it petroleum. And rock oil, when it came about, within a few years, was way 10 times above the peak whale oil. That's the way it worked. Okay. As I said, there's the price. I'm going to skip over this US energy flow thing. Remind you that global warming is real. We don't know how much of it is due to humans. And I'll wind up with that and be happy to stay around for some questions. So thank you very much.